And we're going to identify our limiting reactant for each. So for flask A, what's our limiting reactant there? The magnesium. Right, magnesium was LR, or limiting reactant, which means that our HCl was in excess. Makes sense. That one had the least amount of magnesium. Now flask B.
Is that our control? Isn't it kind of like our control?
Yes, flask B is kind of like our control, as Lily pointed out. And in flask B, we had both of our reactants completely used up. So I'm just going to write that we had a 1-to-1 ratio to let myself know that both of our reactants were completely used. And you can make note of that too. You can say that both reactants were completely used up. Whatever will help you remember what that 1-to-1 ratio stands for. So what does that mean for flask C? You can kind of see it. What was our limiting reactant here?
The
HCl. Can you see the magnesium stuff kind of left over? Stuff. So our HCl was our excess reactant, or limiting. Yes, limiting reactant for flask C. Now, this backpack gets a little confusing, and I got confused with it this morning, so we'll work through this together. I'd like to start with flask B, though, so jump down to that like middle row. And to remind myself, I'm going to write a 1-to-1 ratio right next to my numbers that were given. Now, because we had a 1-to-1 ratio, these numbers here of our initial amount drop down to our amount reacted. Remember I said that 1-to-1 ratio means that our amount of each reactant was completely used up. So, even though it's dropped down here. Now you're probably thinking, Ms. Repas, where did you get the values of moles? Where did they come from? Okay, so I left you space down here where it says flask B. We're going to show our work. So I'm not going to write it on the flask B because if I click, my work's going to go away. So I'm just going to write it right here. So our initial amount of magnesium is 1.2 grams. And this is just a simple conversion factor that we learned so many weeks ago. And we're just converting to moles. So 1 mole goes on top. And the molar mass of our magnesium is in the bottom. When I punch this into my calculator, I magically get that 0.049 moles. Now, converting our HCl to moles is a little bit trickier because we're starting in milliliters. And I know you guys haven't learned molarity yet, but here's your crash course. So I have a 1.00 molar solution, which just means I have a 1.0 mole per liter solution. So that's the molarity of my acid. Now I have the conversion up there on the board underneath the information for the class. So 1.00 molar is the same as 1.00 moles over 1 liter, or 1.00 moles over 1,000 milliliters. Now, in this instance, what would make the most sense to use which of those two conversions? To convert from HCl. The second one. We were given milliliters to start with. Okay. So I had 100 mils of HCl. And I'm going to use the second conversion factor. number of 0.100 moles.
Yes, this is still under the.
Yeah, this is all still under these, but this calculation is the same, I believe, yeah, for all of your initial amounts of HCl. So if you just show it once, maybe like up at the top where it says somewhere, just show that calculation once somewhere.